Okay, so good morning again, everybody. And today we are continuing with the Hooke's law, and we're going to take a look at the experiment for Hooke's law. So this is basically the setup here. If you look, there's a retort stand, two retort stands, one holding a meter rule, and the other one, if you look closely here, right, is holding up a spring, a spiral spring, and there's a little needle that is connected to it there that's used as a pointer. So if you look, the pointer is currently pointing at 50 centimeters. All right, and now what we're going to do is that we're going to add a weight hanger at this point, all right, to see how much the spring will extend by. So the spring extends to just about 51.5 centimeters. So that's an extension of 1.5 centimeters. And as we continue to load this spring with 20-gram weights, it's going to continue to extend. So at this point, it went to 52 cm. So that 20-gram weight, mass rather, would have caused an extension of 0.5 centimeters. As we continue to load more and more of these masses, as you can see, from 52.5 we now went to 53 centimeters, and what we're going to do is that we're going to add these masses, right? And each time we add a mass, we are going to check how much extension the spring is produced by the spring. So this is basically the setup for Hooke's law, right? What I'm going to do, if you can look at the table behind, right? We start with 0, which is without the hanger, then 50 grams, we add the hanger, then 70 by adding 20 grams each at intervals until we get to 170 grams. I would have converted those masses from grams to kilograms, and then found the weight by multiplying by 10 newtons. So each one of the masses will have a weight, all right? And we will also add the length of the spring as we go along. From the length of the spring, we will have to minus 50 cm each, because that's where the original marker was, where the spring was not loaded, where we didn't have the hanger or any of the weights on it. And what we were going to do is calculate the extension. So for example, when we added the 50 grams and we went to 51.5 cm, the spring would have then received an extension of 1.2 cm. All right, and basically, when we are finished with this, I'm going to fill out the table, and then I'm going to send you a picture of it so that you can plot what we call a force versus extension graph. In this case, the force will be the weight, the weights, that's the weight of gravity, right? So force on the y-axis, which is the weights of the different masses, and the corresponding extensions that they produce. All right, so I will send you the table in our Google Classroom. So for now, this is what the experiment will look like. You basically put the spring in there, you set up another retort stand with meter rule so that you can and with a pointer so that you can see how much the spring extends every time you add a weight to it. All right, so that's how we basically go about doing Hooke's law. It's very important that when we do get to the lab and we actually do this experiment, that we ensure that the hanger stops bouncing before and comes to rest before we take our readings. So I'll see you in the next video.